Hi everyone, Adam here again. Welcome to the hardware portion for ELEC 2507 Lab 2. Today we're going to be walking you through the hardware portion. So to begin, let's open up the lab document. And the first thing you'll see is this link to the lab stats page. So make sure you're using this and using your assigned station. So I'll go ahead and find the IP of the computer I'm using. I can either hit connect, which will download a remote connection like I showed you last time. Or this time, I'm just going to show you a different way. You can type in the IP manually, so long as you're connected to the VPN. So, I'll go ahead and open up VPN. Hit connect. Type in my password. And the same message will appear saying I'm connected to the network. So I can go over here and type in the IP address of the computer that I'm looking for. So in my case, I'm working on station 31. I'm making this video for you guys. So I'm going to be typing in the IP address of 191. So that is station 30 is 190. So station 31 is 191. They're all numbered in an orderly fashion like that. So if you have trouble finding your lab station, you know what to do. So it's VLSI / your singular username, and then small p, capital W, student number. So right now when you guys log in, you'll first be greeted with your desktop screen, and the three apps that you guys are going to be concerned with in this particular exercise are the function generator, which is either this logo, or sometimes you'll see it given in this logo with just the Regal, but the other two are just the same. So the other two apps should be called VLSI Lab ELEC 2507 GUI, which controls the potentiometer, and then the scope channel, which is the same as in your last lab, right? So let's go ahead and open those up. Remember when opening your scope to right-click on the properties, find the actual address of the scope, and type that into either Firefox or Chrome. Once you're actually here, you're going to click on Remote Front Panel, and if you get a timeout request, that's fine, just hit refresh. Should bring up all 4 waveforms on the screen. So once you're actually in here, you'll see a bunch of different settings in the VLSI Lab ELEC 2507 GUI. And here's where you can actually set the value of the potentiometer. And the first thing I would do is actually set the mid value. So that means you get the same amplification on channel A that you do on channel B, or channel 1 on channel 2, right? So basically you can go up or down 10. And the value is actually represented here in kiloohms, right? So if I go down 10 on the B value, it'll go up 10 on the A value, and so on and so forth. So you can vary the resistance of either of your channels to get a slightly better waveform of what you're looking for, maybe in this particular portion of the experiment. The other application that's here is the function generator app, right? Which is called Regal DG1022. And on some computers it's just called the Regal app. And from here you can change the frequency, the amplitude, the offset, and the phase and duty cycle of both of the signals on each channel. So when I have either channel 1 or channel 2 selected, I'm only able to edit those parameters. So for example, I have channel 2 selected as in green here, so I'm only able to edit the parameters on channel 2. Switch that to 4 volts. And I could switch that to 1 volt, and then before anything actually applies on the scope, so before it takes effect here, you actually have to hit the send button first, and then it'll take effect. So if I want to change the wave on channel 2, or turn the output off, or turn it to a pulse, or change the duty cycle, or any of those, I need to first hit send before any of that actually takes precedent and actually shows up on the scope. So now that you've seen all 3 apps that you're going to be using for this lab, which are the potentiometer adjuster, the actual control panel for the function generator, and the scope, we can go ahead and start and look at the portions of waveforms that they're asking us to recreate. So let's go down and we'll find the first one here. So this one, at first glance, it looks like it has a sinusoidal property, right? And it also looks like it maybe has some peaks and quick, jagged edges, which would make you think, what kind of wave? Maybe a triangular wave or a ramping waveform? So we'll go ahead back to the function generator here. And first of all, we can use either channel 1 or channel 2 to control our output waveform, which is on channel 4. Right, so let's start with channel 2 and we'll make that one the sine wave. Okay, let's start with a 0 degree phase offset, a 0 degree DC offset, and hit send. So we can see our wave is automatically changed. And this looks like one that we're looking for maybe a little later on in the lab, right? It looks similar to something that we're looking on for later on. So maybe that's already a hint about where you have to go with this. From there, let's switch over to channel 2. So again, hit the channel 1/channel 2 button. That'll switch you over here. And we want to put this one on a triangular wave, right? Which is a ramp. So if we go same, no offset, no phase difference, and the frequency, let's make it double. Yeah, that sounds good. So once we've done that, we can see that we still have some weird kind of things going on, right? Weird kind of patterns. It looks similar to what we're trying to get, but maybe the peaks aren't quite nearly as sharp as we would have liked. So make sure you keep open your document for reference as to what these waveforms should roughly look like. When the TAs are doing your marking here, we're not going to look for exact waveforms. We're not going to look for exact amplitudes. All we want to see is that you guys have learned how to use these tools and played around with the different amplitudes, the different offsets, the different phase angles and duty cycles to learn how to create these different waves. Because that's a very important skill, and it'll transfer over to your next labs and next year's labs as well. So your channel 2, when you're making the broken heart wave, your channel 2 should be a sine wave, and your channel 1 is also a sine wave. Sorry, I meant to say your channel 2 is a ramp, which is a triangular wave, and your channel 1 should be a sine wave, okay? And you want your amplitude of your sine wave to be greater than the amplitude of the triangular wave, okay? And we can see when we have that, we have this kind of inverted looking waveform of what we're supposed to get. If we go back to the Word document, we can see that the waveform that we're supposed to get looks exactly like this, right? So if we just invert this, we would end up with the exact same waveform. So how would we do that? Well, we could either offset the sine wave or the triangular wave by 180 degrees, right? Sorry, I meant 90 degrees. If you offset it by 90 degrees, that'll just invert your waveform. So to get a better actual crest on the other side, you can actually vary the potentiometer, right? So you can vary the values of the potentiometer to get maybe a deeper crest like that, or a narrower crest like that. And once you think it looks good, and you have your values of your potentiometer, your values for your scope, and the actual oscilloscope itself, put them in the frame, and take a screenshot of everything in the photo, and attach that with your report. This is 1, proof that you actually attended the lab. It's 2, proof that your work is different than your peers. And 3, it's an easy way for the TAs to see who just copied last year's examples and who actually did the lab this year. So again, play around with these values. Don't use the same ones that I have here. You can change them slightly. Obviously, everyone's phase will probably be 90 degrees once you have it out of phase, but again, you can play around with your frequencies here, play around with the actual offset, the DC offset, and the amplitudes, and see what happens. Also, make sure to not neglect your potentiometer, as that actually gets you a nicer looking output on your waveform, right? So once that section's done, the next section, figure 16, asks us to create the crags and crest waveform. So this waveform actually includes a sine waveform and a square waveform. And if you actually vary the phase of the sine waveform in relation to the square waveform, you'll find that you'll have something similar to what we're having here. So let's go ahead and do that. So I'm going to go ahead and set channel 2 to a sine wave, and I'm going to set it to 10 volts peak to peak at 1 kilohertz. Again, you can change all these values yourself. I'm also going to start with a phase offset of 180 degrees. I'm also going to switch channel 1, and I'm going to put a square wave there. And I'm going to make sure the frequency of both these waves this time is actually the same. And I'm actually going to decrease the frequency, the amplitude of the square wave down to something like 2 or 3 volts. And once I've done that, I can set the phase offset back to 0 degrees. And we can see we're coming up with something similar to what we should have had, right? But it looks like it's still just a little bit out of phase. So let's go back to channel 2 and keep varying that phase. So let's try 220 degrees. Again, it's starting to look more like we want, but not there yet. So let's go 260. So I keep on varying my phase up, and I'm finding that my waveform actually isn't converging to what I want. So maybe I should now go down. So let's start at 200 again. See what my waveform looks like. That's where we were before, and it looked good, but maybe go down a little more to 150. Oh, and now we're really getting something that we are used to seeing. So maybe drop that down to 130, see what it looks like. Now it looks like we're at the opposite sort of side. So maybe 140 is the kind of sweet spot for that one. And it looks like it is. So if we go ahead and scale that waveform up so that it's a little bit bigger and more pronounced on the screen, then we can also go ahead and adjust the vertical scale so we can see a couple of these in the same frame. But you don't want too many to overcloud the view. So go ahead and take a screenshot of that along with the settings of your Regal function generator and the settings of the potentiometer as well. So again, I suggest you go ahead and adjust the potentiometer to actually get a more balanced looking waveform here. It'll actually bring up and down your crests and crags a little bit, but that's fine. Again, we don't really care that it looks perfect. All we care is that you played around with this stuff and actually experience what the digital potentiometer does, experience what the actual function generator does, and actually how to play around with the scopes functions to maybe increase a channel's vertical scale, increase or decrease the horizontal scale to actually view different frequencies, and also using your up and down buttons to actually move your waveforms up and down on the screen. So those are these ones here. So using all of these is going to be very important. And again, don't use the settings that I have here. Try to come up with something of your own that makes the same waveform. Again, you're going to use a sine waveform, you're going to use a triangular waveform, but again, play around with the amplitudes and play around with the frequencies, because you could, realistically, you can use any frequency wave here that you would like, right? As long as they're the same, as long as the amplitude of channel 2 is greater than channel 1, and as long as there's a phase offset between the two waves, you should find that you end up actually recreating this wave. The next waveform we're asked to recreate is actually the modified stair wave. So in this waveform, it actually takes two different square waves, and by varying the phase angle between the two square waves, you can actually achieve this stepping pattern. So first of all, we're going to go ahead back into the remote desktop. We're going to change channel 2 to a square wave. We're going to hit send. We'll go back to channel 1. Make sure that's still on a square wave, which it is. Hit channel 4. Scale that down a little bit just so we can see it a little better on the wave. And let's make the amplitude of channel 1 4 volts is fine. Let's make the amplitude of channel 2 something like 8 volts. From there, we know that the frequencies of these waves should be offset to actually create that stepping pattern, right? Because if they're on the same frequency, we're always going to have the exact same thing happening at the exact same time. So let's go ahead and change one of these waves to something like 500 hertz, right? And from there, we see that we have a wave that closely resembles what we're looking for. So try to vary the settings in here. Make sure that the frequency of channel 1 is double that of channel 2. Make sure the amplitude of channel 1 is double that of channel 2. But vary the phase degree and the duty cycle to actually see if you can create more or less basically steps in this. And again, I suggest that you use your potentiometer, because with your potentiometer you'll get a more pronounced waveform from either one side or the other, which will allow you in turn to create those higher and lower peaks, right? So I'd say that is somewhere good, and once you have something that's similar to this, again, not using these settings, I'd go ahead and take a screenshot of my potentiometer values, my MATLAB app, along with my oscilloscope screen. And if I want to get a stable screenshot of this, sometimes you'll see that it's moving like that. I can just go ahead and hit single. That'll actually just give me a single screenshot of what's there, so then it'll give me a still screenshot that I can take for my next snipping tool for my report. But when you actually go ahead and rerun your simulations, you're going to want to go ahead and hit run again, or else you won't be able to actually see the updated waveforms on the screen. Last but not least is the broken mountain pass waveform that we have to create. And this waveform is created with a ramp wave and with a triangular wave. Sorry, a ramp wave and a pulse wave, I should say. So let's go ahead and go back into the hardware desktop, and we're going to switch one to a ramp and go ahead and hit send. Switch the other to a pulse, go ahead and hit send. For this one, we want our amplitudes to roughly be around the same value. So say I have 4 volts peak to peak there. I want to fit in roughly 4 volts peak to peak here. The one thing we're going to do is switch this duty cycle back to 50%, like it was before. And then we can see we kind of have something starting to look like what we're trying to recreate. We're trying to recreate that, and we currently have this. So how are we going to get there? Another thing I would do is maybe keep increasing this phase offset, because right now it looks like we're kind of backwards, right? So let's go 180 degrees for now. And then again, it looks quite similar to what we should be left with. But let's go ahead and change the duty cycle of the pulse here. Sometimes this is actually a little buggy and it doesn't want you to change the duty cycle of a pulse necessarily. But if you go back and forth between the channels a couple times and keep clicking on the duty button, it'll eventually actually let you. I don't know if this is a known bug in the application or what. As I make this on the Sunday night before your guys' lab on Monday, I honestly couldn't tell you what's going on here, but trust me when I say it does work. I've seen it work. Vary the duty cycle of your pulse eventually once it lets you, and that will allow you to recreate the waveform that you're looking for. As I pause my recording, I just found a way to do it. So when you're clicking on phase, start hitting tab, hit it about, I don't know, 5 or 6 times. It'll actually highlight this symmetry value. The next time you hit tab, it'll actually highlight the duty cycle. So if you can follow that step, that'll actually allow you to change the duty cycle of the pulse waveform. So go ahead and hit send on that. And then I can see that again I'm starting to get something similar to what I should have, but it doesn't look quite exactly what it should be. So I'm going to go ahead and scale this out for you guys a little bit. And you guys should be doing this while you're following along. As in your reports, the TAs don't want to see little teensy-weensy waveforms in the screenshots. Actually blow them up, make them look big enough to fill the screen. Not fill the screen, but actually be proportional to the other waveforms on the screen, and not take up the whole screen, but be visible enough so that they can actually mark what's actually in the waveform. So right now when I'm at a phase difference of 180 degrees, I can see my waveform is starting to look like what it should, but again, it's just not there. So I'm going to go ahead and keep playing around with this actual phase difference until I find where my waveform actually matches up. And that looks pretty darn good compared to what I was expecting to get. So I was expecting to get something along those lines, and it looks like I have something along those lines. So let's go ahead and actually try to make this a more pronounced looking waveform. So let's go ahead and again play around with the potentiometer over here. So maybe play with the major scale first, so we can see down 10 is actually making the waveform bigger. We can keep making it a little bigger. And at a certain point, it's going to stop getting bigger. But once you're happy with it, I'd say go ahead and hit single again, so you don't get that transient across the screen. Once you've done that, you can go ahead and take a snipping shot of the scope, the function generator, and the potentiometer all at once. You're going to include all 4 of those screenshots in your report. Once again, make sure to not use the same values that I have here, because all your stations are going to be different. I've done this experiment 2 or 3 times, and I've had to put in different values each time. So you're not going to be able to use exactly what I have here. Play around with your amplitudes, play around with your offset, play around with your phase, play around with your duty cycle. I've showed you the main parameters on each of them to touch on. With that said, good luck on the hardware portion, and we'll talk to you guys in lab 3. Bye-bye. Oh, one more thing, if you guys aren't attaching your files, multi-sim files, with your report, the TAs don't have any way to verify that you've actually performed the experiment or actually made any of the circuits that we've asked. So please make sure you do that. I've allowed you to include a PDF file and a zip file of all your work. So if you have multiple multi-sim files, you can attach them all into a zip folder and then put them in your report. All right, good luck guys. Bye-bye.